Hi everyone, welcome to Math 60. This video is about section 2.5. This is solving equations as much as we can if there is more than one variable. So just as a review, I can solve super simple equations like x plus 2 equals 7. I subtract 2 from both sides, and I get that x equals 5. I can solve more complicated equations like 3x plus 1 equals 2 times x minus 8. And I have to do a little bit more work here. First, I'm going to distribute that 2 across those terms, and I get 2x minus 16 on the right side. I still have 3x plus 1 on the other side. Now I get all the x's to the left, and I have x plus 1 equals minus 16. And I'll subtract 1 from both sides, and I get that x equals negative 17. But I still end up with x equaling a number. Unlike the last video, we're not going to run into those surprising situations. However, these situations involve just one unknown variable, but we can also have equations with more than one variable. A very common one that many of you may have seen before is distance equals rate times time. All three of these are variables. Maybe I know the distance, but I don't know the rate or the time. Or maybe I know the time, but I don't know the distance or the rate. Yet we still want to be able to write our equations solving for one variable. So this equation is solved for distance. All right. I would want to know the rate, let's say 5 miles per hour, and the time, let's say 2 hours, and then the distance is 5 miles per hour times 2 hours, which is 10 miles, right? I've solved for the distance, which makes it really easy to plug in the rate and the time. However, that equation is also useful if I know the distance, but I don't know the rate, for example. So I can solve this equation, I'm going to switch to letters, d equals r times t. I can solve that for the rate, for r. Well, if distance equals rate times time, then I can divide both sides by the time, and those cancel out. And I'm left with d over t equals r, or in words, rate equals distance over time. And now the same equation is written where I'm solving for rate instead of solving for distance. And I could also solve this for time. I could solve d equals rt for time, in which case I would divide both sides by rate. And I see that d over r equals time, or that time equals distance over rate. I had to travel 100 miles and I was going 20 miles per hour. Well, that will tell me that it takes 5 hours to get there, for example, right? Because 100 divided by 20 is 5. So we can always solve equations for different variables or different quantities. And moving to a more abstract example, let's say that I have the equation 3x plus 2y equals 10. So we've got this equation 3x plus 2y equals 10. And right now I got my x's and y's on the same side, and they're both multiplied by numbers. So it can be a little difficult to say, well, if I know what x is, I want to figure out what y should be, or vice versa. So to make it easier, we can solve this equation for y, which means basically isolate the y by itself. Same thing as when we're solving to figure out what number y is, but this time y is not going to be a number because it's still going to depend on x. So I take 3x plus 2y equals 10, and I want to isolate the y. So let's start by getting the 3x on the other side. So subtract 3x from both sides, which will cancel here. And I have 2y equals negative 3x plus 10. You could also see that as 10 minus 3x, but this is going to get us towards our slope-intercept forms for functions, so I like to put the x before the 10. And now the y is by itself, but it's still got a multiplication. So to fix that, I'm going to divide by the 2, which cancels, and I end up with y equals negative 3 halves times x plus 10 over 2, which is 5. And I have solved for y. Now, no matter what x you tell me, I'll do a little bit of arithmetic and I can figure out what y is. For example, if x is 4, then I would do minus 3 halves times 4 plus 5, which is, let's see, minus 3 times 2, because 4 divided by 2 is 2, plus 5, which is minus 6 plus 5, which is negative 1, and that's my y value. I could do that as well in my original equation, but it would take a little bit more arithmetic. So solving for y does the arithmetic before you plug in the numbers. And I could solve that same equation for x, kind of like how with distance equals rate times time, we can solve for any of our variables. I could also solve 3x plus 2y equals 10 for x. And to do that, I'll subtract the 2y from both sides, giving me 3x equals minus 2y plus 10, and then divide both sides by 3. Cancellation gives me x equals minus 2/3 y plus 10 over 3, which I'm going to leave as a fraction. And now I know that if, let's say, y equals 9, then I can quickly figure out what x should be. Minus 2 times 9 over 3 is minus 2 times 3, which is negative 6 plus 10/3. Review our fractions. I can't add them when they don't have the same denominator, so I'm going to multiply my negative 6 by 3 over 3. And I get negative 18 over 3 plus 10 over 3, which is negative 8. Sorry. I get negative 18 over 3 plus 10 over 3, which is negative 8 over 3, and that's my x. Solving an equation for one variable by itself, there's not necessarily any reason. I could leave it like this, but when you solve it for one variable, it allows you to use that new formula more efficiently. If I know a bunch of different x's, I can quickly find out a bunch of different y's. Okay, that was an example where the x's and the y's I just had to add and subtract. But let's do another example where this time I have to multiply or divide. So let's look at one where we actually have 2xy equals 10. X and y are both numbers, I just don't know what those numbers are. Right? Now, if I choose x equal to 5, this is going to force y equal to 1, because as soon as I write the 5 there, I'm saying 10 times y equals 10. Aha, y must equal 1. If x is 5, the only number that will make this whole equation true is y equals 1. So I can figure it out that way, but it might be a little simpler if I just solve for one of my variables. So let's solve 2xy equals 10 for y. We want to get y all by itself. And because it's multiplied by the 2x, I'm going to divide both sides by the 2x. Those cancel, and I'm left with y equals 10 over 2x, and the 10 and the 2 cancel, so I have y equals 5 over x. And now you see if I let x equal to 5, then y is equal to 5 over 5, which is equal to 1. That's why the y equals 1 is required for both of those. And if x were equal to a half, for example, that's possible. If x were equal to a half, then y, which is 5 over x, has to be 5 over a half, which is 10. And we'll talk more about fractions and how to do fraction division. But that works out because 2 times a half times 10 equals 10, because the 2 and the 1/2 cancel. Lots of equations end up getting built when your variables are mixed together, either through multiplication or through some type of addition or subtraction. And solving your equation for one or the other variable can make it a lot more efficient in understanding your mathematical situation. That wraps up this video. Thanks for watching.